So friend, welcome again in this our video class, and in this sessions we are going to learn overview of the type C power delivery systems. So here I am going to explain you what happened after we connect type C adapter to the laptop, and how the power flows and how the power reach to the SIO. So I given here a systematic sequence, and I'm going to explain you how that things work. So first, I'll explain you all the sections. Though this is my Type C jack where I'm going to connect the adapter. Then here is a Type C controller chips which manage and control the Type C data as well as the power delivery. Then these are the power path, that is there will be the two MOSFET, and then this is a buck boost converter and the battery charging sections, where the buck converter means the decrease the voltage and boost converter means increase the voltage. Okay, and here is a MOSFETs, and then here is my battery, and here is the bottom, this is the SIO IT8227, and then here are the different buck converter outputs. So here is a 3.3 volt sections, then the 5 volt sections, then the system power supply where the 1 volt and 1.8 volt, which is going to the PCH, and then the DDR4 voltage, that is a 1.2, 2.5 and zero point 0.6, and then the CPU core, and then the graphics core. This sections is normally works in the Type C laptop, which is on after the 10 generations and all. And in 10th generation, the we can know that CPU and the PCH is a combined. Okay, so this voltage is going to the PCH, that means going to the CPU only. So now we'll start. So first, when I connect the adapter, then what happen is the first CC line communicate with each other, like adapter CC line and the laptop CC line will communicate with each other, and then Type C controller request the power via the CC line to the adapter. Then the adapter deliver 20 volt, and that 20 volt come out on the V bus. Okay, and once the voltage come out from the V bus, then the voltage will be come here, and then this Type C controller chips trigger this MOSFET. There will be two MOSFET which get the trigger, and then this 20 volt pass to here, that voltage is become a system voltage system, that is supposed to be a 20 voltage. Then what happen is the next thing is here is a SMBus communication. SMBus is basically a two-wire communications protocol. It's sometimes it's called the I2C bus. So I2C bus and the SMBus both are the same. It's a bidirectional communication protocol where the two chips are communicate with each other. So the once voltage is arrived here, and then the Type C controller chips and the battery controller, that buck boost converter, start with communicating with each other, and then this buck boost converter buck the voltage, that means it decrease the voltage from 20 volt to 13, somewhere around 13 volt, and that 13 volt is coming here at step number 6. Okay, so here the 13 volt or something voltage is coming here, and then this voltage is going to this different buck converters. So here are the different buck converters. So here is a 3.3 volt buck converter. Okay, and here is a 5 volt buck converter. Then the system voltage, that is a 1 volt and 1.8 voltage, and then here is a DDR4 voltage, that is a 1.2, 2.5 and 0.6, and then the CPU core, and the final is a graphics core. The all this power enabled by this SIO. Here is a SIO, and SIO is a control and manage all the power. But before that, SIO should get a 3 volt to work. So here are this 3 volt section which have linear voltage also and the buck converter also. So once he received the 13 voltage from this buck boost converter, then the 3 volt will be generated, and that 3 volt is called 3 VLP. And this 3 VLP voltage at step number 8 is going to the SIO. So once SIO got this 3 volt, then it started communicating with the EC bias and start functioning, and then it communicate with this SMBus and communicate with the Type C controller chips, as well as buck boost converter as well as the battery. So now if my adapter is missing, suppose we remove the adapter, then this he'll come to know the CC line will be 0, there's no communication. Immediately this information is given to the SIO, then SIO asks battery to generate the voltage, and then this buck boost converter, what he do is he trigger this MOSFET, and then the voltage will travel, the battery voltage will be travel from here to here and is given out to the system voltage. So the output voltage either coming from this adapter or coming from the battery, okay, via this line. So in this way, this basically a system work. So it's a very simple to understand first, but only thing is here everything is control by some communication protocol via this SM bus as well as in CC line. So I hope you understand this concept. Thank you very much.